Okay, everyone, thank you for joining us for today's webinar on remove structural ambiguity with the reliable velocity model. So remove structural exactness with the reliable velocity model using our newest tool, VelPro. So today's presenter, Hilda Bada, she is our geoscience technical advisor in CGG. She's responsible for pre- and post-technical cell support and training services for our clients who use Inside Earth and VelPro, as well as Hampson Russell. She actually worked on a number of areas before joining us. She has over 27 years in the industry. Her focus is on seismic interpretation, 3D geological framework, mapping, velocity modeling, and AVO analysis. She holds a master's in integrated reservoir management from University of Venezuela, and she has been working on various projects worldwide. She has extensive knowledge of well and seismic data management and multi-platform environment. She's based in our Crawley office. So just an overview, quick overview of CGG's software commercial offerings. They provide advanced software to help E&P companies develop a better understanding of the subsurface, manage exploration and development risk, and maximize the potential of reserves. You can see our whole portfolio spans everything from seismic interpretation to imaging, velocity modeling, advanced interpretation, AVO, reservoir characterization, all the way into reservoir engineering. For the focus of this webinar, we're going to focus on velocity model building using VelPro, and with that, I'll hand it over to Hilda to get started.
Okay, good afternoon, good morning, everyone. Thanks for joining us in this webinar. We are just about to start in the all the material regarding to VelPro. So you can see in here, VelPro is a post-stack velocity modeling package. It provides a flexible and scalable solution designed to integrate our horizons, faults, well top seismic and velocity information. It's part of the suite offered in CGG GeoSoftware. Which one is the problem that we have commonly when we are interpreting? The drilling is in depth. All the information that we are getting from the wells is in depth, and the seismic information is normally record and interpret in time, and we need to establish a link in between those all domains. And the way to do that is creating a velocity model, and then we have the option to depth convert information in one domain to the other. For today, the outline for our webinar is check the available workflow that we have for depth conversion, learn how to build the velocity model, see the calibration process, learn about the layer analysis, depth-to-depth workflow, and finally, after the presentation, we will see a demo, and then we will have the opportunity to see the software, how it works and how to get things done. In VelPro, we have 4 workflows, 1 solution. We have the structural independent workflow. In the case that we have only seismic velocities, we can create our velocity model interpolating the seismic velocity into 3D volume, calibrate to well control, and use this calibrated velocity to depth convert. If we can have the opportunity to add more accurate interpretation on that, and we have our time horizons done, we can go ahead and create the next workflow, which is the layer-based modeling. We can use horizons and fault, and we can create a layer definition. And in this case, we have plenty of control, how to manage stratigraphically all the information inside the volume, how to calculate things, how they will be extrapolating the data. Then, after creating the velocity model, we can go ahead and depth convert the information. And of course, when we are going to match the data, the well data, and the seismic depth converted, normally we have a small misties. It's the common problem that we have in our workflow. And then we have to, we can proceed to the depth-to-depth conversion. And in this case, we are creating depth migrated volume, and then we can use this depth correction volume to correct the seismic and to adjust the information of the horizon depth converted and then tie that to the well. The last workflow that we have inside Velpro, which is an additional module, and it's not covered in this webinar today, is the pore pressure prediction. And what we do in this one, we are just reading the well data, normally the sonic and density, and we can derive the equations. And with this equation, we can create volumes and the pressure volumes, and then use those volumes as an input for another software. The whole workflow that we have in using Velpro, of course, creating first the project, loading the data. After that, the first thing is QC the data, mainly the velocities and check shot. And of course, at this point, we already have interpretation done, and we are quite familiar with the area, so we know exactly what we are doing when we are looking in the QC data, what we need to edit. After that, another additional option that we have is we can play before creating the velocity model to establish which one is the best algorithm for that. We can just go ahead and check using the velocities and test with different grading techniques, and then get the best grading parameters to calculate our model. Finally, building the 3D stacking velocities. With this one, we have already the volume created. At this point, we can consider that as a final product. We can then proceed and do another tool, which is the calibration. And we can select the data, display the check shot, QC the check shot. We can do some editing on that, create a calibration volume, and apply this calibration volume to our velocity volume made with the velocities. After that, we can then go ahead and do the layer analysis. With this one, we have the opportunity to specify on each layer our velocity model with different tops and base, specify different events, apply different equations for each of the different layers that we have. And another important thing here, and in this layer analysis, we can apply different techniques for every layer, and we are using the information, mainly the velocities. We can do that also with the check shot. After that, if we can have the opportunity to go ahead and create our pressure volumes, we can use the pore pressure prediction volume. But one thing that I want to emphasize in here, this is not the output of the pore pressure prediction is not used in Velpro to calibrate or to modify our velocity model. It's an additional model that we have, and we can just use that module to create an output file which can be used in another software. In Velpro, this is the simple user interface. In this case, there is an example display with some horizon in that, wells, and the data that we can manage in Velpro. For the wells, log, check shot, well tops, directionals, velocities, horizons. You don't need to, you don't have to have all of them to create the velocity model. However, if you have all of this information, it's going to be more robust. But if you have only check shot data, you can go ahead and create your velocity model with that. It's not limiting, but these are only the well data types that we can manage in Velpro. This is a quick workflow in the independent structural independent workflow using seismic velocity, doing the QC, interpolating, doing the calibration, and then we can either export the volume or go into depth conversion. The first thing that we normally do is displaying the velocities. We can display those velocities and do editing on that. We have several tools to play with that and modify our velocity when we see an anomaly. We will see in detail how they works in the demo at the end of this seminar. We have different options to edit and sample. We can work that in a graphic from a line, then we can display the velocities, or we can display single points, and in this case we have the graphic that we have at the right top. We can test several grading parameters and then test how the grading is working in our velocities, and determine if we are happy with these numbers, or we are happy with the trend that we are getting in our velocities on that. And this is an example of the display what we do when we are testing and checking the grading parameters. After that, we are ready to start building the velocity model. Again, this is a simple interface. In this window, we have the option to add a velocity field, check shot, sonic, or add volumes. We have to set up, of course, the name of the volume that we are creating. In this window, we can use the select the data extension, and automatically the software will read X and Y, min and max for all the data available in the model. Also, we can play with the detail, how small or how big is going to be the grading detail on that, the cell size. Another option that we have in here, if in this case, if this is a simple example, if we are just working in with only one range, you can click on that, add the range, and in this example, we are working with only one off in 5 seconds, and specifying in this option the flex grading, which is one of the different grading techniques that we have. If you are working offshore, you have the option also to home your velocity model to the water button. Just select here the right option and set up the velocity that we have. Click on proceed, and then we can display our velocity model. When we are using and adding layers in the velocity model, we have different options to play and define the stratigraphy on it. As you can see in this example, we have in the first event between the horizons blue and orange in this example, and we are using Concordant to base, and then the interpolation in the velocity model is just parallel to the base, but when it's going closer to the top, is pinching out in here, and then this is the way that the software will calculate depending with the option that we are selecting in the stratigraphy. So it's quite important because sometimes we need that just leaving as proportional, or in another case is critical if we set up correctly concordant to top or the base. That's the way it works, and these are the options that we have to play with that. In the calibration, when we are working, we need to calibrate our velocities using the well check shot, which is on very important data that we have measuring the well. We display the check shot using the tool in the function manager. We display those check shots, select the calibration function here. We have different options, just selecting that. We can extend those check shots, we can move in different ways in that. We can play with the shaping that, and we can control how the editing is working, checking that in the different colors in the right part. When you can see the control function, the uncalibrated volume, which is in red, and the calibrating volume in green. Once that we are happy with the editing in here, we save this calibration function and create the calibration volume. To create this calibration volume, just go in the option from the menu. When we are selecting here is our calibration function edit. In our example, we say that's as average. Select the velocity due to match. In this case, we are using only stacking velocity at this point. and create the output grid for that. Is this going to be the calibration volume? And this is an example in the cross-section how the calibration volume results are. And then once that we have the calibration volume, we can proceed and select our initial velocity volume, apply this calibration volume, and we can get a calibrated velocities. What we are doing in the calibration process is just reading the check shot, reading the velocities. The software is doing in the algorithm what it has to do, applying the correction factors, creates the velocity of the correction volume for those calibration functions, and then we apply this calibration function, and you can see here the difference, how it was between the initial model and the calibrated model. This is a better view on that, and you can see the some trends on that are changing from left to right. Moving forward in the next part of the workflow, we can add an additional data type. In this case, it's going to be seismic horizons. We are using the layer analysis to calculate the best equation for every event, and we construct the layer-based model in the velocity model. How it works. In our layer analysis, we have to select the horizons, top and base, and the corresponding peak name for the top and base. We can add the check shot that we have available for the wells in our project. And if we have velocity available, we can add those velocities also. When we click on OK, we are getting this window. These representations are in the color, the circling colors are the velocities. The black triangles are the check shot of the wells. And the red triangles that we have in here, very small, are the well peaks. And what the software is doing is trying to calculate the trend of these values using a combination between the interval velocities. When we click on Fit, it will select and calculate the best equations and the constant value for that equation. We can even play with these sliders in here and modify that, but normally when we click on Fit, what the software does is just analyzing all the data on it, and it's creating according with the equation. We have many more equations on that. It creates the equation for the specific layer. Which layer? The one that I select in the top and base here. Then we can create a layer velocity model. This is a very quick example how to create that in different layers. I'm using a couple of layers with constant values, and I'm using one of the layers with the results of the layer analysis. In this case, I select the equation for a specific trend on that, and automatically the software set up the values according with the constant calculated in the layer analysis. This is an example of the display in the cross-section. As you can see, we have only this small variation in the layer that I applied the equation, and the rest are constant. If I want to update my volume, it's quite simple and easy. Just going in the option for velocity float, open the window there, select the layer that I'm working on, and do the editing that is required. You can see an example here in my initial model, and then after applying some editing in one of the layers, in this case we are in the final layer using the velocity model from another volume, and these are the difference that we are getting in editing the model. After creating the model, when we convert the information, normally we have some misties between the well tops and the depth converted horizon, and that's why we are going to apply the next workflow, which is the depth to depth. In the depth convert horizon, what we are going to do is calculating this small misties in here, because we have difference between the well peaks and the horizon depth converted, and we are trying just to get those element type. The workflow for that, after creating in the first part our velocity model, either with velocities only or apply the layer velocity modeling, we can just go ahead and calculate the well top residual from the misties. Then with those values, the software is creating a whole volume according with those misties. And this is a depth correction volume, and we can apply this depth correction volume directly to our volume in depth, applying the residual depth and generating the final volume corrected. The option for that, from calibration, we have the mistie analysis. And this is an example here in the graphic. We have the different well tops, and we can notice a small difference in some of them. After depth converting, the domain in this case is velocity versus depth, and we can notice that the horizon doesn't match with the different well tops. When we apply this mistie analysis, what the software is doing is just calculating for each well the difference in between the well top and the depth converted horizon at that location. And this is a very good and important window, because we can identify any mistake in here if we are expecting something small like this, 2, 3, 5. And when we are looking at those kind of difference, we have to go in these wells with this top and check if maybe I just selected the wrong geological top, or perhaps I was picking the time horizon where it was in a different event. So we have to go back and check what happened in here when we have those big difference. From this window, we can add the pairs to create the correction volumes, and most importantly, we can export directly this information to create the depth correction volume, and then we are ready to do the calibration in depth. This is an example for how to calibrate the depth seismic data. We select the seismic file in depth. We set up the output for that. The format that we need is, we have several options here, and you can just edit and set up a specific format. And we need to select the depth correction volume in this part. With this correction volume, we are applying the correction to this depth volume, seismic depth volume, and created another seismic depth volume already correct, without going back in time domain and do the correction in time. This is a zoom in the detail where the well peaks is, and we can notice when we haven't before applying the correction that we have the well top in here, and the horizon corresponding to that top is a little bit higher. After applying the depth correction in depth-to-depth workflow, we can match the horizon corrected in here exactly where the well peaks is. What we are doing in the depth-to-depth. And depth-to-depth, it calculates the misties of all the wells at once. Only one table selecting the pairs and a specific horizon and well peak, and the software will calculate for the whole area the mistie table. It creates a mistie residual correction volume, because from that table we can export the data, and then it applies this residual correction directly to the depth volume, which means that we don't need to send back this to time, applying the correction in there. every time that we are sending information from one domain to another, we are building up errors. So if we are avoiding the fact that we have to convert to time back this information from depths, we are just avoiding adding an additional mistake in the versus volume. And the other good reason is we don't need to reprocess the data because we can correct directly our PSDM volume in depth. In summary, in VelPro we can load well depths, log seismics and velocities. We can use different techniques per layer. We can calculate the kriging parameters and apply the kriging technique in our calculation for the surface. We can update the existing model and we don't have to rebuild from scratch. We can do the layer analysis. Additional, we have the module for the pore pressure prediction. And when we are working with the big volumes, while we are waiting for the processing, calculating this velocity model, if it's taking some time, we still have the option to continue working with VelPro because the software is unlocked. So you have all the menu options available, so you can do another task. And finally, we can convert seismic grids, horizon, and flat files. In the next part, I'm going to show now a demo. This is the software, the main window. In this case, for us, in order to save time, we have already prepared this project with the information loaded on it. We have wells, the wells with the check shot, well tops, and log curve. We have velocities, and we have also horizons in time. Okay, then after creating the volume, loading the data, we can start working with the first thing. I'm going to show some tools that we have to modify QC the data, edit and save the changes. In this example, we have the stacking velocities. We can display these velocities in different ways. We have the option to select display as an outline, short point, or interpolated values. In the selection, I can select that as a single point. I can select my point, select the window. I can click on few ones. Every time that I click on one velocity, I can display different velocity functions on here. Some edits that we have available on it. In this case, in edit mode, the typical option for move, delete, and insert point. And also we have the freehand, with when you notice something that is you are not looking good. We have another edit mode. Just fix higher, fit line, using it that way. And the other option that we have is the fit spline. I set up 2 points as an anchor, and then I can just play with my logs and then try to edit. Okay, and you can do that with all the functions. When you are happy with the changes, just go and save the changes. In this case, I'm not going to change that. Let me just ignore for a while. The other option that I have, I can select that as a line, and it's quite nice because I see in the cross section. I have to do an extra thing here. Okay, toggle on the edit mode and then select the function. Perhaps I noticed something in here that I'm not that happy. You can just select function in there. The option to edit are more or less the same. In edit mode, moving, editing, inserting, freehand, okay? And you can do the same in the same way as you were working with the points, okay? You can play in that and change different views in here, different cross section, or you can reselect from the map, okay? I'm not going to save for a moment, and let me just go back in here. I don't want to save. I'm going back and display my velocities in here. Once that I'm happy with my velocities, if I need to do another some of the changes in that, I can do it in the graphic one by one. And I have another option that is sometimes useful. If you want to remove some bad points, you can use the option in here to, for example, delete. Inside the polygon, just create the polygon, and then it's removed automatically. Okay, it's another one way to clean up the data. Okay. All right. The next part, then let's go and create the velocity volume. To do that, create the velocity volume in here. I'm going to do simple with my stacking velocities. You can add check shot or velocity field or sonics if you have. I'm going to work for this demo only with this stacking velocity. And then just set up the name of that. Click on use the data extent. Play with yourself. I have already created the velocity volume. It's only to show you how quick it works. Let me just select the flexing by default. But we have radial, we have kriging, square, fixed value, block kriging, and triangulation. For simplicity, I'm going to select only the flex. I'm going to add this range. And in my case, I have my time horizon for the water button. And let me select it here. I'm going to set. And then I'm ready to go. And it's calculating in here, and then I can just continue working with my software as usual. When it's finished, I will select, will receive that notification that it's done. Okay? Complete. What is created in that? We have the velocity volume in here. We have this example is the stacking velocity volume. This is an example in there. I'm going to show you what happened in here in the cross section. When we select the cross section, this is an example what can I show in there. Okay, I have another which is we can see better. Let me just reselect the other one. Okay. And in this example, this is a cross section, and we can see that we have here, in this case, is time, our horizon, some fault, well peaks, the wells, and the velocity that we have in here is a ledger velocity model. Which one is then? If I want to edit, I need to go in here and velocity float. Select my velocity volume. I have already different layers calculated for that. In this case, I selected two of them with constant values, and I select that one with a equation. If I want to edit one of these, quite simple, just select that one, editing. In that case, this layer I have a constant velocity. I'm gonna change and select another volume, and the volume that I'm going to use is stacking velocities in that range. Okay, so I modify only the latest one. I can save my velocity volume with the same name. It's saved. I go in here and I have to reselect that. And here we are. There's a constant velocities. This applied with the equation, and this one read from another volume. So this is the way that we can play with that and edit the velocity model very quick. Okay. To create this layer, how to create this layer? We have the option in Tools to create the layer analysis. Applying a new layer there. I'm going to select a couple of events in here. So it's this one. With the top. See, the other one is in red. Okay. Select my pairs of horizons and well peak. I can include my check shot. And okay. Oh. The velocities. Okay, and then in this example, we can see that we have a couple of well outliers. And mouse button 2, it gives me the name of this well. In this case, it's on the number 2, and this is the number 3. And those are a couple of wells that I have to check what happened with the check shot of the well peaks. Something is running there. I have different equations in here. If I'm working in time, I have the velocities equation based on time or based on depth. Some of them available on it. When I click on hit and fit, it will create the train on that. It will create the constant values, and then I can create my point set and save my point set in here. I'm not going to save it because it's done in this case. And then the software is saving in the point set, and I have the point set already available in that part of the tree. With this point set, I can create my grid, or I want to go in, if I want to go back in the velocity flow, when I select that in the layer, and I editing any of my function, the only thing I need to do is select the equation to use, click on select, and I have my grid available. When I select this grid, automatically the software will populate all the values. And in that way, this is the link between using the layer analysis, creating that grid, and applying this grid with the equation in the proper layer. Okay, so those are examples of how we can calculate and create that. This is for this part of the process. This is the final model. Of course, it's not accurate, but it's for learning purposes. That's what we are showing here. Not how good it is. The idea is just to show how to do things. In the next part, we can proceed and depth convert the information in time to depth. Select the grid in here. You can select all of them in a bunch. Select the velocity model. And then if you want to append any suffix, it's not necessary because the software will put those grids in a specific place of the project. But if you want to, you can add, for example, depth, whatever, and then click on proceed, and it will calculate everything in depth. In this case, it's done, and we have all the grids in here already created on that. Let me just switch off that, select the grids, Okay, and we have the grid depth converted using the velocity model. Next part, when we are going to compare the depth conversion of the time horizon with the well peaks, we have, as always, difference. To play with that, we have the misties analysis. What it's doing in this case, there was on a previous session. I'm going to select the previous session. Or if you want to start a new one, the way to do it is at the wells, because remember that in misties analysis we are going to compare the well peaks with the horizons. Then I have every column for the wells. Okay. In the add pair, in setup, I can select a specific horizon in depth and the corresponding well peaks. When I add that, I have the pairs in here. Just select all of them, and I have automatically generated my table. At this point, I can check if I have any problem with the well peaks or the horizon, because this is these are the difference between the depth conversion and the well peaks. What I'm going to do in here, I can export this data. This will generate the well peaks with the residuals, plus it's going to send automatically this information to generate the depth conversion volume. When I select this option, it's sending me giving me all the information that is working with all those tops and the well peaks residual. When I click in Save Data and Export menu, it's opening this window to generate the depth correction volume. This is the volume that I'm going to use to depth correct my seismic information in depth. Only select the name of that. Again, we can play with the cell size if we want to change the detail, but normally by default is taking the cell size from the input data. When I select in here proceed, it will create this depth correction volume. At this point, it's created already. Let me just switch off this. Okay, and this is the depth correction volume creating from the let me select that, from the well peaks. And this, as you can see in here, those are all straight lines, because remember that this is the depth correction volume. This is the volume that is going to be applied to do the correction for the seismic data. Okay, let me just go back in here. And then what happened? When I selecting my data, just opening that. Okay, this display with the velocity volume, we are using the domain in depth. And then you can notice that we have some problems between the well peaks. This is the orange top, and this is the depth converted horizon. After applying the correction, what I'm doing in here, I'm calculating with this well peak point set. It was generated from the depth to depth correction and the misties analysis. You can activate the well peak residual, and you can see at the well location all the difference. Okay, with this one, we can create a grid for this residual. And this grid of the residual is applied to the original depth converted grid to create the corrected horizon. After doing all this operation, we can display it here, okay? And you can see again the domain. Let me just put it bigger. The domain, velocity, and depth. And then now you can see that the well peaks in the lower part is the original, the converted. In the upper part is the corrected orange top. And you can see how it can match. And it was created using the misties analysis and doing all the operations automatically to calculate the right position of the depth, okay? And basically that is what I wanted to show, and I think that we went through all the workflow, how to QC the data, how to create the velocity model, edit, display, and the depth correction, depth to depth conversion workflow. Okay. So, well, there's this point. This is the final part of the demo. Let's go back into the presentation. Put it in here. Okay. Any questions? I see now Jasmine has another option to capture the question.
Actually, yeah, I think, so for the sake of time, I'll only ask one question that we have here, because we do have a couple that we'll have to follow up after the presentation's over. But one question we can ask real quickly: how can we build a velocity model combining 2D and 3D seismic surveys? Good question.
Yes, you can use both formats. You can use 2D data and 3D volumes.
Okay, great. And like I said, for the sake of time, we'll follow up with the rest of the questions after the presentation. But if you would like to learn more or how to contact today's presenter and get some more information, so you can visit, there is a website dedicated to our velocity modeling packages, and also on the website, and I will be sure to send these links out to everybody, we have additional webinar series that are featured on demand for other EMP topics. We also have software tips and tricks to help you unlock powerful functionality. And we also offer a 30-day free trial for the package we presented today, and you can also find our training for the rest of this year on our website. So for contact information, we do have worldwide software support and regional contacts, which can be visited via these links up on your screen. And if you have additional questions for the presenter, please feel free to email her, hilda.bada@cdg.com. And if you'd like more information on other tools or products, send an email to gs.solutions@cdg.com. And with that, we thank you for joining today's webinar.